Hello everyone. So today we're going to talk about the Michaelis Menten equations that is related to our enzyme kinetics. So before going to the derivation, at first we have to know the normal enzyme substrate reaction. That is, whenever an enzyme will bind with its substrate, it will form the enzyme substrate complex, and then it will form the enzyme and product. Now after this, this reaction is an unidirectional reactions, but always the enzyme substrate reaction is not the unidirectional reaction. Sometimes it's follow the bidirectional reactions rules. That means sometimes after the formation of enzyme substrate complex, this enzyme substrate complex will dissociate from each other and they will return to their back state, that is enzyme plus substrate. And on the other hand, sometimes after the production of product by the enzymatic reactions, these enzymes and product will get associated with each other and they form the enzyme substrate complex again. Now the rate constant through which the enzymes and substrate will get associated with each other and form the enzyme substrate complex is known as the association rate constant, that is the K1. Okay, and the rate constant through which this enzyme substrate complex will get dissociated and form the enzyme plus product is known as the K2. This is the dissociation constant rate for forward reactions. Okay, now in case of backward reactions, whenever this enzyme substrate complex will get dissociated from each other and form the enzyme plus substrate by following the backward reaction, in this case the dissociation constant will be the K3. On the other hand, whenever this enzyme plus product will get associated with each other and follow the backward reaction to form the enzyme substrate complex, let's suppose in this case the association constant will be K4. So K1 here, K1 is acting as the association constant for enzyme substrate to form the enzyme substrate complex in case of forward reaction, and K2 is here acting as an the dissociation constant for forward reaction to form the enzyme plus product. On the other hand, K3 is here acting as an dissociation constant for backward reaction to form the enzyme plus substrate from enzyme substrate complex. And K4 is here acting as an dissociation constant for backward reaction to form enzyme substrate complex from the enzyme plus product. This is what about the normal enzyme substrate reactions. Now if we talk about the derivation of Michaelis Menten equation, then before going to the derivation, at first we have to know the 8 most important things, because the 8 most important things is very much essential to proceed for the derivation of Michaelis Menten equations. If you don't know these important things, then maybe you will be able to perform the derivations, but it will be quite more tough to understand this derivation or to perform this derivation. So now I am going to talk about the 8 most important things. That is, the first thing, whenever at the initial stage, the concentration of product will be 0. Now why the concentration of product will be 0 at the initial stage? Just because, let's suppose there are total 8 enzymes, that is E1 to E8, and there are total 8 substrate, that is S1 to S8. Okay, now let's suppose among of these 8 enzymes and 8 substrate, only 3 enzymes are ready to bind with their substrate, that is enzyme 1, enzyme 2 and enzyme 3 are ready to bind with their respective substrate, that is the S1, S2 and S3. Now all of these 3 enzymes and 3 substrate will bind with each other and they form the enzyme substrate complex, that is the E1 S1, E2 S2 and E3 S3. Now among of these 3 enzyme substrate complex, only E1 S1 further follow the forward reaction and they form the enzyme 1 plus product 1. But the rest of the 2 enzyme substrate complex will not follow the forward directions, and instead of following the forward direction, they follow the backward direction and they return to their previous state, that is the E2S2 and E3S3. That means in this case you can see that the three enzymes will follow the forward direction and form the enzyme substrate complex, but after forming the enzyme substrate complex, among of these three enzymes, only one enzyme follow the next forward reactions to produce their product, but rest of the two enzymes will not follow the forward steps, they follow the backward steps to return their previous state. That's why initially, the very initial of these reactions, the concentration of product is little bit low compared to the enzyme substrate, compared to the concentration of enzyme substrate complex, because in this case the concentration of enzyme substrate complex is 3, but the concentrations of enzyme substrate products is only 1. And among of this three enzyme substrate complex, two enzyme substrate complex has already performed the backward reactions to return their previous state. That's why the concentration of enzyme substrate complex is little bit higher compared to the enzymes and product concentration. As the product concentration at the very initial stage is very low, that's why we can neglect the concentration of product. It's negligible. So the updated reactions will be enzyme plus substrate will form the enzyme substrate concentrations, and then this enzyme substrate concentration will further enzyme substrate complex will further follow the forward reactions by using the dissociation constant K2, and they will produce the enzyme plus product, and here the association rate constant will be the K1. Now what to say, this enzyme substrate complex will further follow the backward reactions, okay, and they will get dissociate from each other and they form the enzyme plus substrate. But as the concentration of product is very negligible, that's why this enzyme plus product will not follow the backward reactions, and as they will not follow the backward reaction, that's why we can erase these reactions, and that is associated with the K4 rate constant. So this will be the updated reaction of enzyme substrate complex. Now that is the second important thing will be the total amount of enzyme. Total amount of enzyme, that is the E total is equal to the free enzymes plus free enzyme plus substrate bound enzyme. Plus substrate bound enzyme. Here the free enzymes, here the free enzyme is this one and this one, because the active site of these enzymes right now it is completely free, and this enzyme will have to bind with its substrates. On the other hand, if we talk about these enzymes, then the active site of these enzymes is also free, because these enzymes is already produced its product. That means these enzymes will have to bind with its next substrate to produce the enzyme substrate complex. That means both of these enzymes is right now acting as a free enzymes. That's why this is what about the free enzymes. This is what about the science of free enzymes, and this is the enzymes which is associated with its substrate. That means these enzymes will be considered as an substrate bound enzymes. That is ES. Okay. So this is what about the total enzymes, and in this case, if you find out the free enzymes, the value of free enzymes, then it will be E total minus ES. This is the value of free enzymes. This is the second most important thing, that is you have to know to perform the derivations of Michaelis Menten equation. Now the third most important thing is the V initial, the initial velocity, that is V0 will be the K2. This is the K2 K2 dot concentration of S. This is whatever the sense of V initial. In this case, if you find out the value of S, then it will be V naught is divided by K2. This is whatever the value of S. Now the fourth most important thing is Vmax. That is the maximum velocity, and the Vmax will be the K2 dot the total amount of enzymes. This is the value of Vmax. Now the sixth most important thing is the Michaelis Menten constant, that is the Km. Km will be considered as an dissociation constant by association constant. Now here, if you see the enzyme substrate reaction, then you can see that here the association constant is K1 and the dissociation constant is K2 and K3, because K1 is responsible to perform the forward reaction through which the enzyme substrate will bind with each other and they form the enzyme substrate complex. Here enzyme and substrate is associated with each other. That's why the K1 is here acting as the association constant, or the rate of association constant. On the other hand, K2 here is acting as a dissociation constant, or the rate of dissociation constant, by which rate the enzyme substrate complex will get dissociated with each other and form the enzyme plus product. That's why K2 is here acting as a dissociation constant, rate constant, and K1 is acting as the association rate constant. On the other hand, if you talk about the K3, then K3 is also here acting as a dissociation rate constant, because if you see the reactions, then you can see the enzyme substrate complex will follow the backward reaction to form the enzymes and substrate by using the K3 rate constant. That's why K3 is here also acting as a dissociation rate constant. That means if you follow the Michaelis Menten equations, then according to the rate constant of Michaelis Menten equations, it will be the dissociation rate constant by association rate constant. So here the dissociation rate constant is K2 plus K3. K2 plus K3 is divided by K1. So this is what about the rate constant of Michaelis